In today's lesson, we'll be learning how to factor a perfect square trinomial and a difference of squares. Here are the key concepts for today. We've already seen some of these shortcuts. This is the difference of squares shortcuts, and this is the shortcut when you are squaring a binomial. However, today we are factoring instead of expanding. In our first example, we want to factor this trinomial. Let's begin by rewriting the question. X squared plus 6x plus 9. Before we do anything, let's take a look to see if we have any common factors. The greatest common factor of 1, 6, and 9 is 1, so we can't really do anything there. And there is no variable that is common to all of these three terms. Therefore, we can't factor anything out at this point. What you want to do is you want to think of two numbers when multiplied together gives you positive 9, and you want to think of two numbers when added together gives you positive 6. That should be pretty easy. The answers are positive 3 and positive 3. So you would factor this trinomial to x plus 3 multiplied by x plus 3. This simplifies to x plus 3 squared, because anything multiplied by itself can be simplified by using an exponent of 2. However, there is another way of coming to the same conclusion. You don't have to use this, but you can if you are dealing with a harder question. So let's begin by rewriting our question, which is x squared plus 6x plus 9. The first thing you want to do is you want to look at the first term and the last term, okay? And you want to see if you can square root the first term, which would be x, and you want to see if you can square root the last term of positive 9, which is 3. Once you get these two answers, you want to see if twice the product of these two answers is equal to the center term of 6x. And guess what? It is. This means you have a perfect square trinomial. This is the shortcut you learned previously. A squared plus 2ab plus c squared, when factored, is equal to a plus b squared. Now, if we use that pattern up here, a would be x and b would be 3. If you don't believe the work is right, you can always expand this by using FOIL. And that is a separate way of factoring a trinomial, provided that it is a perfect square trinomial. In our second example, we want to factor this trinomial. Let's begin by rewriting the question, which is 4x squared plus 28x plus 49. Before we go any further, we want to see if there are any common factors. So if you look at 4, 28, and 49, you want to find their greatest common factor. Their greatest common factor happens to be 1, so we can't factor anything out, really. And you want to see if there are any variables common between these three terms, and there aren't. Therefore, we cannot common factor anything out, and we have to leave it as is for now. So, using what you've learned before, you're going to think of two numbers when multiplied together gives you the product of 4 and positive 49. Okay? And you're going to think of two numbers when added together will give you the sum of positive 28. Now, these are some really large numbers. So if you take 4 and multiply it by 49, you're going to get some humongous number of 196. Now, I don't know about you, but finding two numbers that multiply to 196 and that add up to 28 can be pretty difficult and time-consuming. So there must be a faster way of doing this, and there is. You want to use the method I just showed you in the previous example. What we're going to do now is we want to look at the first term, and we want to look at the last term. Okay, so you want to try to square root that first term, and you will get 2x. Next, I'm going to try and square root my last term, and that becomes 7. And let's just double check to see if our suspicion is correct. So you want to double the product of these two answers, and you should get 28x, because 2 times 2x is 4x, and 4x times 7 is 28x. This means that a perfect square trinomial is present. I'm just going to rewrite the shortcut. A squared plus 2ab plus c squared. That factors to a plus b squared. Okay, so instead of writing a, our a is 2x. Instead of writing b, our b is 7, and all of that is squared. And again, you can always double check your answer by using FOIL. In our third example, we want to factor this binomial. Let's rewrite it. X squared minus 100. Before we proceed, let's see if there are any common factors. The greatest common factor of 1 and 100 is 1, so you can't really do anything there. And there is no variable common between these two terms. Therefore, we have to leave this binomial as is for the time being. So, I want you to take a look at the first term of x squared and the last term of 100. Let's see what happens when I square root these. So the square root of x squared is x, and the square root of 100 is 10. Okay, so let's take a look at the pattern for a difference of squares. So if you have a squared minus b squared, that simplifies to a minus b multiplied by a plus b. So in this scenario, a is x and b is 10. If you square x, that would become x squared, and if you square 10, that becomes 100. Therefore, a difference of squares is present, and you can factor it into x minus 10 and then x plus 10. In our fourth example, we want to factor this binomial. Let's begin by rewriting it. 98a squared minus 450b squared. Before we proceed, let's see if there's a greatest common factor. So let's look at 98 and 450. I'm not going to do the work for this, but if you check, the greatest common factor of 98 and 450 happens to be 2. Next, we want to see if there are any variables that are common between these two terms, and there are none. So I'm just going to put NA. Therefore, what I want you to do is I want you to divide each term by 2. And when we do that, a 2 goes out in front of the brackets, and that becomes 49a squared, and then you have 225b squared. Now I want you to take a look at the terms inside the brackets. You have a 49a squared and a 225b squared. It is very possible that difference of squares is present, but let's double check that to make sure. So I'm going to square root 49a squared, which gives me 7a. And then I'm going to square root 225b squared, which gives me 15b. Now, if you recall, the pattern here is a squared minus b squared equals a minus b multiplied by a plus b. Therefore, in this scenario, a is actually 7a and b is actually 15b. So let's rewrite this as 2 bracket 7a minus 15b multiplied by 7a plus 15b. And if you want, you can double check your work because 7a squared is 49a squared and 15b squared is 225b squared. So this is another way of factoring a difference of squares. The only difference between this example and the previous example is that you had to common factor out a number.